Good morning, students. Today we are going to start the topic of states of matter and kinetic particle theory in chemistry. So concentrate yourself. We are going to start. First, we are going to read the definition of the matter. Matter is anything that occupies space and has mass. Now we are going to read the states of the matter. Matter can exist in three physical states: solid, liquid, and gas. Table below shows the properties of the three states of matter. And this is very important question as far as papers are concerned. This normally comes in the paper. So here are the properties, and one by one we will discuss that property in solid, liquid, and gas. So first property is the shape. The shape of the solid is fixed. The shape of the liquid is not fixed. Take the shape of the container. The shape of the gas is not fixed. It takes the shape of the container. Volume. Volume of a solid is fixed. Volume of a liquid is fixed. Volume of a gas is not fixed, same as volume of the container. Density of a solid is high because particles are closely packed with each other. Density of the liquid is moderate and density of the gas is low. Compressibility of the solid cannot be compressed because particles in the solid are already closely packed with each other. Compressibility of the liquid cannot be compressed, and the compressibility of the gas highly compressible. Here is an exam tip for you people. When drawing the diagrammatic representation of a liquid, the particles ought to be drawn sinking towards the bottom and not evenly spread throughout the container. This is due to the gravitational pull. An example of the error in drawing below, no sign of the gravitational pull. So this is an error because there is no sign of the gravitational pull. Representation should be particles ought to be drawn sinking towards the bottom. Here is another error. When gas arrangement is asked for, the particles must be drawn very far apart, and to represent randomness, the particles cannot be drawn in a systematic and orderly manner. An example of error in drawing below. So this is an error. Now we are going to read kinetic particle theory. This is another very important question. So concentrate yourself. The kinetic particle theory is a model used to explain the properties of the matter. The main points of this theory are given below. The first point is all matter is made up of tiny discrete particles. And the explanation of this point is different substances have different types of the particles with different sizes. In a solid, the particles are closely packed in an orderly manner. In a liquid, the particles are loosely packed in a disorderly manner. In a gas, the particles are distributed very far apart in a random manner. Next point of the kinetic particle theory is the particles are always in constant motion. The explanation of this point is in a solid, the particles can only vibrate about a fixed point. In a liquid, the particles move around freely, sliding and rolling past each other. In a gas, The particles move around at random and at great speed. Next point of the kinetic particle theory is the kinetic energy of a particle increases with temperature. Explanation is the higher the temperature, the faster the particles move. At a fixed temperature, lighter particles move faster than heavier particles. Next point of the kinetic particle theory is the average kinetic energy of all the particles is directly proportional to the absolute temperature. At a fixed temperature, all particles of a substance do not have the same kinetic energy. Some particles have very high kinetic energies, while some have moderate energies and others have very low energies. Based on the kinetic particle theory, description of the arrangement and movement of the particles in the three states of matter are summarized in table below. Arrangement of the particles in a solid. They are orderly packed and closely packed. Arrangement in liquid. Disorderly packed, loosely packed. Arrangement of particles in gas. Random, very far apart. Attractive forces between particles in solid, very strong. Attractive forces between particles in liquid, strong. Attractive forces between particles in gas, very weak. Next, particle motion in solid vibrate about a fixed point. Particle motion in liquid roll and slide past each other. Random motion. Particle motion in gas move about at great speeds. Random motion. Next is energy content in solid, low. Energy content in liquid, moderate. Energy content in gas, very high. Here we are going to read an example. The question is, how would you describe the state of the particles in a dilute solution of the sugar? So, dilute solution. Particles in a solution are water molecules and sugar molecules because solution of the sugar is given. In a dilute solution, there are more water molecules than sugar molecules. Sugar molecules widely separated, randomly distributed, and moving at random. Water molecules close together, randomly distributed, and moving at random. Because in dilute solution of the sugar, there will be more water molecules and less sugar molecules. The next topic in the lecture is interconversion between states of the matter. So we know there are three states of the matter: solid, liquid, and gas. And now we are going to read the interconversion between the states of the matter. Matter can change its states. Change in states of matter is reversible. This change can be brought about by pressure and temperature. By applying a high pressure, a gas can be changed into a liquid. By changing temperature, a change in state can be brought about. Figure below shows the interconversion between the three states of matter caused by absorption or evolution of the heat energy. And here is the figure. If we are given a solid, if heat is increased, this solid will be converted into liquid. If more heat is increased, this liquid will be converted into gas. And if heat is evolved, gas will be converted into liquid. If more heat is evolved, liquid will be converted into solid. Some solids directly converted from solids to gas on heating, and some gases directly converted from gas to solid on evolving the heat or cooling. So this was the topic. Read it again carefully and make your notes. Thank you so much.